Here, four data structures are given as four options, and we need to find out the data structure in which we can add or remove elements at both ends but not in the middle. If we see the first option, that is linked list, in linked lists we can add or remove elements anywhere with some constant number of operations. Hence, this is not the correct option. And if we see option B, that is stack, in stack we add and remove elements at only one end, that is top of the stack. Hence we can eliminate this option. In queues we add elements at rear end and we remove elements from front end, but we cannot do both operations, that is both addition and deletion at same ends. Hence we can also eliminate option C. Option D is dequeues. Dequeue is nothing but a special type of queue in which we can add or delete the elements from both ends. That is, we can insert or remove elements from front end, and we can also do the same operations at rear end also. Hence here correct option is option D. Infix notation is given and we have to find out the equivalent prefix notation. In infix notation, the operators are in between the operands, whereas in prefix notation, operators are written before the operands. So the given infix notation is, the given infix expression is a plus b minus c into b minus c into d. While converting one form of notation to another form of notation, we have to convert according to the precedence of operators. Here this inner expression is evaluated first, so we have to convert this expression into prefix first. So the expression would be minus bc into star d. Here these two are operands for this operator, so the prefix notation for this would be a plus star followed by minus followed by b, c and d. And here these two will be operators for this, these two will be operands for this operator. So the prefix expression would be plus followed by a followed by star minus b, c, d, which is option B. It is given that n elements are inserted into the binary search tree randomly, and we have to find out the height of the binary search tree in average case and worst case. So in order to solve this problem, we should know what is a binary search tree. Binary search tree is a binary tree and it should satisfy the following properties. First one would be elements in the left subtree should be less than the node. Left subtree, elements in the left subtree should be less than root. Elements in the right subtree should be greater than root, and left subtrees and right subtree should also be binary search trees, should also be BSTs. If a tree satisfies these three conditions, then that tree is called binary search tree. Here, if the elements are inserted in ascending order or descending order, then the resultant tree would be like this. Or like this. Then the height would be order of n, where n is the number of elements. This will happen when the elements are in either increasing order or decreasing order. The elements are not in the increasing order or decreasing order, and if we get the resultant binary search tree as complete binary tree like this, then the height would be order of log n. So this would be the worst case and this would be the best case. So here the correct option would be option C.
In this problem, the given limit is root over 1 minus cos 2 times of x minus 1 by x minus 1. Now we know that cos 1 minus cos 2 theta is nothing but 2 sine square theta. Just will substitute that value. Limit extends to 1 root over 2 sine square theta is x minus 1 here by x minus 1. Now we can write this as limit extends to 1 root 2 times of modulus of sine x minus 1, because it could be positive or negative. Now this can be written as root 2 times of limit extends to 1 modulus of sine x minus 1 by x minus 1. If I consider the left hand limit, that is limit extends to minus 1, that is 1 minus modulus of sine x minus 1 by x minus 1. This will be minus of limit extends to 1 minus sine x minus 1 by x minus 1, and root is always there, which will be minus root 2. And if I consider the right hand limit, which is root 2 times of limit extends to 1 plus, then the modulus will be positive sine of x minus 1 by x minus 1, so that the limit will be 1. Now left hand limit is now, that is 1 into root 2, which is equals to root 2. Now left hand limit is not equal to right hand limit, because left hand limit is minus root 2, whereas right hand limit is root 2. So as they are not equal, limit does not exist. That is option D.
Agile software development use feedback rather than planning as their primary control mechanism. The feedback is driven by regulate, test and releases of software. Which process does it use? So usually if you want to have a feedback mechanism, each time when some sort of release is there, we need to take the feedback from that and we need to improve from that feedback. So we need not to develop rapidly the total application. So based on the feedback given by the customers and all, we need to go for the development. So for that, so iterative procedure is better. Iterative procedure is the best method for getting the feedback controlling mechanism. So option B is the correct. Iterative method is right.
A grammar is given and we have to find out if there are any conflicts in the construction of SLR parser. And if we write the augmented grammar for the given grammar, we'll be getting augmented grammar as this. And if we draw the state transition diagram for the augmented grammar, we'll be getting the state transition diagram as this one. In the state transition diagram, total there are 8 states, I02, I7, and if we see second state, if we see the state I2, in that state there are 2 actions, shift action and reduce action, and the shift action is on symbol is equal to. So here this parser will have shift reduce conflict on on symbol is equal to, which is option D.